モネードグラスについたレモネード夏のしずく眉をしかめてスパイネ揺れる君のフレースカットレモネード恋の火がついたらレモネード冷やしてあげるさ小粋な仕草グラスに踊る僕をうっとりさせるよ君は風はヒュルヒュルラプソディ君は気まぐれスイートレイディ夏のかげろ君は僕は知らぬ間に夢の中風はヒュルヒュルラプソディ君は気まぐれスイートレイディレモネードグラスに残るレモネード夏のしずくレモネードフレッシュレモネードレモネードフレッシュレモネードレモネードフレッシュレモネードレモネードフレッシュレモネードレモネードフレッシュレモネードレモネードフレッシュレモネードレモネードフレッシュレモネード
All right, here's a preliminary drawing of a screw. This screw is a 2-scale drawing of the screw that we pulled from the soldering iron. Because screws play such a ubiquitous role in the workshop, we're going to need to understand them, and we're going to need to add them to our inventory, which means we need to understand how they're made and how they work. This is a small screw, does a small job. Its job is to securely hold this plate onto the soldering iron plate, those holes. How does it do that? We seem to understand intuitively that if this screw was straight up and down and did not have its threads, did not have the spikes, then it would simply just move in and out of the hole without any problem, which would not be a very useful operation in keeping a soldering iron together. The point behind making the threads like this is because we're trying to maximize surface area. We want to try to maximize how much material is in contact with each other from the two places. These screws screw into plastic, and so we want to make sure that as much plastic is enmeshed within these threads as possible so that as vibrations happen in the world around the screw and its home, it stays in place because it's gripped on. It's holding on tight because it's got so much surface area, and it's holding onto that plastic so hard from all these different places. And it's not like it's holding on really hard. It's just holding it on in a lot of places. And so in aggregate, it holds on tight. The more you turn it, the more material you're interacting. You're rubbing more material against the threads. We also understand that the screw cannot simply release itself. It cannot simply fall out because of the way the threads are designed. The next job of the screw has to do with mechanical advantage, which is where Engineering 101 comes in. Mechanical advantage is the benefit that we get from the screw. Right, the screw helps us do something. It helps us hold the soldering iron together. How well does it do that? Well, Mr. Warden, you must be thinking to yourself, surface area does not beget force. The screw is organized like an inclined plane wrapped helically around this axle, around this shaft. And what the inclined plane allows one to do is translate rotational motion from the screw, turning the screw into linear force. And that linear force is keeping the screw tight in with the plastic housing. Because there's so much surface area, there's so much friction, it's not likely that the screw is going to unwind itself. And so that energy is then basically trapped in the object. It's basically allowing us to store our muscle energy for later. Because what's the alternative, right? The alternative is we have to sit here the whole time and hold this together with our hands. That would be silly. Right? That would not be an invention. That would not be a tool. That would not help. And so we then have to be able to store our energy for later and utilize it over a very long period of time, sometime before the screw fails. And that's what we're going to do here. So if we go in here, we're going to screw this in. We can hold the tool together over a long period of time without worrying about it coming undone. That's the power of the screw. That's what the screw does. Cool. Got it? Awesome.